Hello, my name is Gianfranco Valero, and I'm doing this for software engineering as the independent project that was assigned for Fullsail University. What I will be implementing today is a 2D collision detection, which is that I learned through the use of this tutorial that I found on YouTube by user Abhinav, and which taught me how to implement collision detection in Unity. Now, the feature that I wanted to implement is that depending on the state of the player, be it through the consumption of a power up or some sort of some or the other, that the reaction that an object has to collision changes. So, uh, if you would like to see, this is the finished product. As you can see, I have two different enemies. The first one that just walks over me, I am the black square. I have it coded so it always works towards me, but only walks, doesn't really follow me intensely. And as you can see, if we collide, and that's it. But now I've consumed the power up, right? Now watch the other enemy. Now that I collide into him, he's going to follow me because that's my state for that power up. It makes others follow me. I can collide into the other one, and then they will both follow me no matter where I go. And if I hit X, I reset their behavior again. If I collide into them, you can see that he starts to follow me again. So this would be the behavior after consuming a special power-up or just changing the player's state from regular to this. Then if I reset here again, you can see if I consume this one, I have a different effect. As you can see, he's now flip-flopping around me. This would be again another different behavior that you could implement into a game. You have them both. They're all scale, so they eventually try to be the same. And here they're colliding with themselves because it's a scale so that it will always try to run back to a minimum length between you and it. I just hit X to reset the behavior. And that will be it. Again, just to demonstrate a little bit further, they can be the different types of behavior can happen at once. So now this guy is supposed to follow me. I just reset him. I make this guy follow me, and now he's following me. And now it changed. You see? Okay, very well. Anyways, the way I did this was through the implementation of scripts that I had not used before in Unity because I had not used it at all. And I also learned the very basics from the tutorial, but then I had to research more online. So here, as you can see, I just have this is my player move script. I have two scripts: my player move script and my enemy move script. And well, this is just my player state. Well, it's just a property for that. And when I update it, I'm just getting the input on the horizontal axis. So that's how, by pressing the right arrow key and the left arrow key, you update his position, the player's position. And here I have a check for space, where if it is on a type of ground, any ground, now this could be the player or a platform or anything, then he can jump, but otherwise if he's already in the air he can't jump again. I will demonstrate this quickly again just to show. Here if we go, doesn't really matter, I just do this. As you can see, I'm here, they're trying to follow me, that doesn't really matter right now. I can jump, but I can't jump again. I'm on top of them, I can jump, but I can't jump again, no matter how hard I hit the space button. Here I can jump, but I can't jump again. I can jump off of them, but I can't jump again. And that's the implementation of that, just to check for a little bit of added realism. Not much, and really. Then here, this for just debug. This debug log just print out a message to the Unity's console, and I just use this as caveman approach to debugging, just to make sure that everything that was being hit when I needed it to, because since there are no breakpoints in Unity, you have to do stuff like this so you can test. And over here, this is just a check because to make sure that the ground is reset to true, because otherwise if you would hit a player, an enemy I mean, and move back, it wouldn't reset the fact that you're on the ground to true, so you couldn't jump again. Again, just exiting, when you exit collision with anything that's in the game, just set the fact that you're on the ground to false, and that's literally it. And here, the enemy move script is where I really change everything. So I had to learn how to have cross-script communication or so, and you do that by since I only have one object, I just use this function that finds the object type of the type that you provided with, and you have to cast it so it can catch it correctly. And this is just what I explained before. You press X to reset its enemy state. So here there's a switch with the enemy state. So if the enemy state is 0, and it has an initial speed, that's the one that moves towards me, then I just do some checks that make it always move towards me, just like only on the X. And then if it's 1, then it's homing, or something like that. Then just so it doesn't like really crash onto you, I just have a check for the magnitude. Well, the magnitude of this temporal vector that I always make, which is a vector from the item, from me to the item that whose behavior I'm trying to change. So here in case 1, I just make this vector, which is based on like I just explained, and that's what I use to have the behavior of the object be to follow you through the X and Y, as long as its magnitude is less than 1.5. Then in case 2, that's the one where it was originally going to be orbiting around you, but since it has collision, it can really fall through the floor if you set it, and then it wouldn't have enough force to make it go back up. And instead what I opted for was having it be doing like a semi-circle around you. And then I just, to do that, all I had to do a little bit, because I had to find the angular velocity vector, which is always perpendicular to the original destination vector that we use for the first behavior. And so to have an orthogonal vector to it, a perpendicular vector, so all you have to do is really negate one of the two values. So that's why I did this particularly here. Then all I had to do, a check here just to scale it, just so it wouldn't go off, because as it's increasing with every check, it would just fall off really quickly off the stage. So to like cap it and to bring it back, I did this where I'm scaling it by half. And well, I just had to implement a couple of different checks where if the check it's more than or equal to, if the objects is more than or equal to the player's object's y, sorry, and it's going left, then you have the translation of it going left, and if it's not going left, otherwise going right, then you have the translation of it going right. And then just checking whenever it hits the ground where it is, so I can reset the boolean that tells it what direction it's going. Here, this is where you change the states. This is the change states. What changes to change state 3 are just the name of the objects that I collide with to change my player states. And when I collide them, I just destroy them and set the player state. What else? Well, here, if I am then depending on my player state, I have the enemy act accordingly. So if I'm in 0, I don't do anything. If I'm in 1, then I put it to enemy state 1, which is the homing one. And if I'm in 2, I set to enemy state 2, which is the one that does the half circle motion. Well, I think that this feature could be cool if worked on more over a longer period of time, and could be really interesting. But I hope you enjoyed it, and that was my presentation. This is Jean-François Valero Hernandez for Software Engineering at Full Sail University.